Well, let's look at one more example together, and this time we're going to graph this function here. Again, we start out by factoring the numerator. The numerator is going to factor into, are there any factors of 1 that add to give me -1? Well, no, there aren't, so the numerator is as simplified as it's going to be, and I can't reduce it, so this is just not applicable in this case. Now we're going to talk about symmetry. Okay, so the symmetry of this function. The symmetry says that if I'm looking for odd symmetry, then I'm either going to have all the signs in the numerator be opposite, so that would look something like what? -x squared plus x minus 1 all over the same denominator. Or I could have x squared minus x plus the same numerator over the opposite signs in the denominator. So we're going to plug in -x into this function. -x squared minus a -x plus 1 all over -x minus 1. So this first term is just x squared plus x plus 1 divided by -x minus 1. So I don't have either of these two cases, so there is no symmetry in this particular case. Now let's move on to finding the x and the y intercepts. So again, when I find the x-intercepts, that's where I let y be equal to 0 and solve the function. So my function again was x squared minus x plus 1 divided by x minus 1, and we're setting it equal to 0 and solving. So when I multiply both sides by x minus 1, that just leaves me with x squared minus x plus 1 equals 0. And from here, I know that this doesn't factor, so I can't use trial and error. So the next best thing is to do this using the quadratic formula, right? Because that's the other way for me to be able to solve for x in this particular case. So the quadratic formula says x is equal to -b, so negative of -1, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Now let's look for just 1 second at this, what's underneath the radical here. This says 1, well, -1 squared, which is just 1, minus 4. So 1 minus 4 is -3, meaning that I'm not going to get, I can't take the square root of a negative number, so I'm not going to have an x-intercept here. No x-intercept, because I can't solve that and get real numbers. Okay, so that's one thing we know. What else do we know? Let's talk about the y-intercept. Again, the y-intercept is when we let x be equal to 0 and solve for y. So if this is my function, then we have 0 squared minus 0 plus 1 divided by 0 minus 1. So this is a 1 divided by a -1, which would be -1. So when x is 0, we have a y-intercept at -1. That's what we know so far. Let's talk asymptotes now. We have vertical asymptotes, and that's where the denominator equals 0. If you remember, the denominator of my function is at x minus 1. So we say x minus 1 equals 0, or I have a vertical asymptote when x is equal to 1. Now how about the horizontal and slant asymptotes? I'm going to rewrite my function here. It's x squared minus x plus 1 divided by x minus 1. And we need to talk about the degree of the numerator, which is a 2, and the degree of the denominator, which is a 1. Well, when the numerator is greater than the denominator by 1, we have a slant asymptote. So we have to use long division, don't we? So we're going to do x minus 1, divide that into the numerator, x squared minus x plus 1. And we're looking for that linear equation, y equals mx plus b, right? So what do I multiply x by to get x squared? Well, that's just an x. So x times x is, oops, erased too much there. X times x is x squared. X times negative 1 is a negative x. Change your signs though, so we have a minus and a plus, meaning that we get 0 here and a 0 here, and we actually are done because this would be kind of a remainder. So I found out that this y equals x is the equation of my slanted asymptote. So now we're ready to sketch what we know. And I'm going to mark off my graph so that we can sketch it. Okay, so I have my graph marked up here. I know that I had a vertical asymptote when x was equal to a positive 1. So let's sketch that first. Here's my vertical asymptote going like this at x is equal to 1. I also had a slant asymptote for y is equal to x, which is actually that function right there. Y is equal to x, because that would be rise 1, run 1, rise, run, rise 1, like that. Okay? What else do I know? I know that I had a y-intercept at 0, negative 1. So far that's all that I know, and now I'm ready to put it into my calculator. So you can see here that I have the numerator in parentheses divided by the denominator in parentheses, and when I show you what the graph looks like, it looks like that. And you can kind of start to visualize where that slanted asymptote is, as well as where my vertical asymptote is. Okay, so now I know how to sketch the thing, and I might be interested in that point right there, maybe that little dot that I have, which I can tell you is going to be occurring at 2, 3. I can either trace that or I can plug that value in. And so let's go now, let's find some additional points just to make this thing a little bit prettier. Okay, so I know that I have something happening here in this center section just from my graph. So what happens when I let x be equal to a negative 1, because I want to know what happens over here, and then I'm going to go inside of this asymptote, or really, really close, and I'm going to choose a negative 0.2. And then I'm going to go on this other side. And remember how I think something's happening over here, right? Because I know that my graph kind of bottoms out there. So I'm going to choose the number 2. Now, if I choose those values and plug them into my calculator using the table function, you can see that when x is negative 1, I have a y value of negative 1.5, and so forth. So I'm going to transfer those values over here. So I have negative 1.5, negative 1.05, and 3. So I'm going to use this value right here to help me sketch this portion over here. So I'm at 2, 3. And then I have these values over here which are telling me that I'm getting really, really close, and I'm going to go like this. Okay? So this is how I would sketch my function using a slant asymptote, along with maybe not always having x-intercepts.